Okay, for the second example of integration by parts, this one's a little bit more tricky than the last one because if I look at my two basic functions here, x cubed and e to the x squared, now I know how to derive and find the integrals of x cubed, but for e to the x squared we don't have a rule for the integral of this. I can differentiate it though. So if I went down that path, let's see what would happen. So since I can differentiate this, I'm going to call this u, and I'm going to call this dv dx. So in that case, du dx equals 2x e to the x squared, and v therefore is the integral of this x cubed dx, which gives me x to the 4 on 4. Now, so if I have a look, putting those together is just going to give me x to the 5 e to the x squared on 2. And that's no better than what we had before. In fact, I don't know, maybe it's a bit worse. But I can't have the other rearrangement. So the trick here is to recognize that this I can find an integral for. So what we do here is we actually, as a first step, rewrite this as x squared times x e to the x squared dx. Because now this I can find the integral for. So I'm going to make this part my v, or u, call it u, and this part my dv dx, and so that gives me du dx is equal to 2x, and my v is equal to the integral of x e to the x squared dx, which actually gives me a half e to the x squared plus c. So you can see if I took the derivative of this like we did before, I'd have 2x multiplying down, the 2's would cancel and I'd get this here. So you can solve this one by using integration by substitution, so making e to the u, etc. there. And so now putting this together, I get that x cubed e to the x squared dx is equal to u times v, so this is u and this is v, so I get x squared on 2 times e to the x squared minus the integral of the other elements put together, so I have now had here u dv dx, now I want this multiplied by this, and now I actually get again, because it's 2x times half here, the 2's cancel, I get x e to the x squared dx, which I can actually integrate. So this gives me x squared on 2 e to the x squared, and then minus, here I'll have e to the x squared on 2. Then I can do a little bit of simplification as well. So let's make this e to the x squared outside of x squared minus 1 all over 2. And then of course plus constant of integration. So as you can see, it's a little bit more complicated, but now notice before, when we've got these multiplications of x, if I did it the other way around, I'd go up, but going down I can sort of get these reduced powers that I need to integrate.